Schmidt Hammer test versus core test. How we really check concrete strength. When a building is finished, how can we really know if the concrete inside those columns and slabs is as strong as it should be? We can't just break a column in half to find out, right? That's where two essential methods come in, the Schmidt Hammer test and the concrete core test. Both help engineers check the actual strength of concrete after construction, but in very different ways. In this video, we'll see how each test works, what their results really tell us, and when to use one over the other. Let's start with the Schmidt Hammer test, also called the rebound hammer test. It's a non-destructive test, which means we can test the concrete without damaging it. Here's how it works. A spring-loaded hammer hits the concrete surface with a standard impact force. The hammer then rebounds, and the device measures how far it bounces back. That rebound distance, called the rebound number, is related to the surface hardness of the concrete. The harder the surface, the higher the rebound number, and generally, the stronger the concrete. But this test doesn't measure the entire strength. It's mostly about the outer few millimeters of concrete. So what can go wrong? A lot. If the surface is rough, wet, carbonated, or covered with plaster, you'll get misleading readings. That's why standards like ASTM C805 or EN 12504 recommend testing at least 10 spots per area, cleaning the surface, and averaging the middle values while ignoring the extreme ones. This test is quick, affordable, and great for quality control or comparing areas, like checking whether one batch of concrete is weaker than another. But remember, the Schmidt Hammer gives an estimate, not a guarantee. Now, if we really need to know the true compressive strength, we have to take things to the next level, the core test. This one is a destructive test because we physically remove a piece of the concrete. Here's the process. A core drilling machine with a diamond-tipped bit cuts a cylindrical sample, usually 100 millimeters in diameter and about twice as tall. That core is labeled, sealed, and sent to the lab, where it's trimmed and tested under compression. The result gives us the actual in-situ compressive strength, reflecting everything: material quality, compaction, curing, and even site workmanship. However, the test must follow strict standards like ASTM C42 or BSEN 12504-1 because the shape and size of the core affect the strength value. For example, a short, fat core gives a higher strength reading than a tall, slender one. Also, the location of the core matters. We avoid drilling near edges, rebar, or critical load zones. And after testing, the hole must be filled with high-strength repair mortar to restore the member. The core test is slower and more expensive, but when accuracy matters, like in disputes, quality failures, or load testing, it's the gold standard. So, which one should you use, the hammer or the core test? Well, that depends on what you need. Let me put it simply. The Schmidt Hammer test is like a quick health check. It tells you how the concrete surface feels, strong or weak, but not the full story. It's fast, non-destructive, and great for quick inspections or trend analysis. The core test, on the other hand, is like a blood test. It takes longer, costs more, but gives you the exact internal strength, no assumptions, just real data. That's why in professional projects, we often use both together. First, perform the rebound hammer test to map surface strength variations. Then, take a few cores from suspicious areas to verify the true compressive strength. In fact, combining both gives a much clearer picture, and many standards recommend correlating rebound numbers with core test results for reliable conclusions. So, next time you see someone tapping a concrete wall with a strange silver device or drilling a perfect cylinder out of a beam, now you know exactly what's going on. Both the Schmidt Hammer and the core test are vital for ensuring that our structures are safe, durable, and built to perform exactly as designed. Testing isn't just about numbers, it's about trusting the structure beneath your feet. If you found this helpful, don't forget to like, subscribe, and share it with your fellow engineers and site mates. See you in the next video, where we keep building smarter, safer, and stronger.